September 30th, 1944. Somewhere in the Siegfried Line, Germany, the 703rd Tank Destroyer Battalion received orders that would change everything about how American forces could fight German armor. After months of combat with M10 Wolverines, watching their 3-inch guns bounce off Panther glacis plates at ranges where German crews could destroy them with impunity, the battalion was converting to a new weapon system. The M36 Jackson 90mm gun, the most powerful tank-mounted weapon in American service. Lieutenant Charles Morrison watched the first Jackson roll into the battalion's assembly area, its angular turret and long gun barrel making the vehicle look predatory, despite being mounted on the familiar M10 chassis. The crews gathered around, touching the cold metal, measuring the gun barrel's length with their eyes, calculating what this weapon might mean for their survival. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Germans had spent 2 years building an armor superiority that seemed unbreakable. The Panther combined sloped 80mm frontal armor with a 75mm high-velocity gun that could kill Shermans at 2,000 meters. The Tiger's 88mm gun and massive armor made it nearly invincible from the front. American tank crews had learned through bitter experience that engaging German heavy armor head-on was suicide. Tank destroyer doctrine offered a solution, but only if the guns were powerful enough. The M10's 3-inch gun struggled against Panthers past 500 meters. The M18 Hellcat's 76mm gun was better, but still inadequate against heavy German armor at combat ranges. American forces needed something that could match German firepower, and they needed it desperately. The 90mm M3 gun, mounted on the Jackson, represented America's answer to this crisis. Originally developed as an anti-aircraft weapon, the gun had been adapted for the anti-tank role with remarkable success, but specifications on paper don't reveal how a weapon performs in combat. For that, you need soldiers willing to test its limits under fire. October 1944. The first M36s entered combat in France. Initial reports were cautious. Yes, the gun was powerful. Yes, it could penetrate German armor that had previously been immune to American weapons. But the Jackson also revealed immediate problems. The massive muzzle blast from the 90mm gun obscured the crew's vision, making rapid follow-up shots difficult. The open-topped turret, designed to save weight and improve observation, left crews exposed to artillery airbursts and small arms fire. Crewmen complained that firing the 90mm gun in October's cold rain felt like standing inside a thunderstorm. The concussion rattled teeth. The flash temporarily blinded gunners trying to observe their shots. The smoke lingered in the turret, making it difficult to breathe during sustained engagements. But then, something remarkable happened. American ordnance engineers, responding to urgent requests from tank destroyer battalions, developed and deployed a modification faster than anyone thought possible. By early November 1944, less than a month after the Jackson entered combat, a double baffle muzzle brake was being retrofitted to all vehicles. This wasn't just a minor improvement. The muzzle brake reduced recoil forces, stabilized the gun during firing, and dramatically reduced the muzzle blast that had been obscuring gunners' vision. More importantly, it allowed crews to achieve rates of fire that would shock both American commanders and German opponents. The 703rd Tank Destroyer Battalion, now fully equipped with Jacksons, began conducting their own testing under combat conditions. They needed to understand exactly what their new weapon could do, not in the controlled environment of Aberdeen Proving Ground, but in the mud and chaos of actual warfare. What they discovered would challenge fundamental assumptions about how armored combat should be fought. The testing began with basic questions. How quickly could a well-trained crew load and fire the 90mm gun? The manual specified procedures, but manuals are written for ideal conditions. Combat introduces variables that no testing ground can fully replicate. A Jackson crew from the 703rd Company A volunteered to push their vehicle to its limits. They selected a derelict German vehicle as a target, positioned it at 800 meters, and began firing for sustained rate of fire. The loader, Corporal James Webber, had spent 3 years operating the M10's 3-inch gun. He knew how to handle heavy ammunition, how to position himself for maximum efficiency, how to maintain rhythm under stress. The 90mm rounds were heavier, bulkier, more unwieldy. Everything suggested the rate of fire would be slower than the M10. It wasn't. Weber and his crew achieved something that surprised even their own commander. Loading cycle after loading cycle, the 90mm gun fired with a rhythm that shouldn't have been possible for a weapon of that size. 6 seconds between shots, then 5 seconds. At their peak, during a sustained minute of firing, they achieved rates approaching 10 rounds per minute. This was faster than many German tank guns of similar power. The 88mm KUK-43 gun on the Tiger II could manage perhaps 4 to 6 rounds per minute with an experienced crew. The Panther's 75mm gun was faster at perhaps 8 rounds per minute, but it lacked the raw, penetrating power of the American 90mm. The implications were profound. American tank destroyer doctrine had always emphasized mobility and surprise over armor protection. Hit the enemy before they can respond, then displace before return fire arrives. The Jackson's rapid rate of fire added a new dimension to this philosophy. What if you didn't need perfect shot placement? What if you could fire 3 or 4 rounds in the time it took the enemy to fire twice, creating a volume of fire that overwhelmed German gunnery discipline? But rate of fire meant nothing if the gun couldn't penetrate German armor. The 703rd Tank Destroyer Battalion's after-action reports from November 1944 document systematic testing against captured German armor plates. They fired standard M82 armor-piercing capped rounds at various ranges and angles, measuring penetration and documenting results with the precision of engineers rather than combat soldiers. At 1,000 meters, the 90mm gun could penetrate approximately 120 millimeters of vertical armor plate. Against the Panther's sloped frontal armor, this translated to marginal penetration capability. A perfect hit might punch through. An angled hit would likely ricochet, but the Panther's side and turret armor were vulnerable at all practical combat ranges. More significantly, when the rare T-30E16 high-velocity armor-piercing rounds became available, performance improved dramatically. These tungsten carbide core rounds could penetrate over 170 millimeters at 1,000 meters. Even Panther frontal armor became vulnerable. The crews learned to aim for specific weak points. The turret ring, where thinner armor protected the mechanism. The sides and rear, where even standard ammunition could achieve kills. The gun mantlet, where proper angle could allow penetration into the turret interior. German tankers had grown accustomed to frontal invulnerability. Panthers could advance confidently, knowing that most American weapons couldn't hurt them from ahead. The Jackson changed that calculation. Even without the premium tungsten rounds, a Jackson could threaten a Panther's turret and achieve side shots at ranges where the Panther crew might not even realize they were under fire. December 1st, 1944, near Eschweiler, Germany, Lieutenant Alfred Rose of the 814th Tank Destroyer Battalion was conducting a routine patrol when he spotted movement at extreme range. Through his telescopic sight, barely visible at the maximum range of his optics, a German Panther was maneuvering along a road. The distance was absurd. 4,600 yards, more than 2.5 miles. At that range, the Panther was barely recognizable as a tank. The round-trip time for the shell would be several seconds. Wind, temperature, the Earth's rotation, all would affect trajectory. No sane gunner would attempt an engagement at such distance. Rose ordered his gunner to take the shot. The first round fell short, impact visible as a temony, distant splash of dirt. Rose observed, calculated, adjusted. The second round also missed. On the third shot, impossibly, the armor-piercing round struck the Panther squarely. The German tank stopped moving. Rose continued firing, alternating armor-piercing and high-explosive rounds. Within minutes, the Panther was burning. The 814th Tank Destroyer Battalion's after-action report documented the engagement with clinical precision. Range: 4,600 yards. Target: Mark 5 Panther. Result: destroyed. Witnesses: multiple personnel confirmed the hit. This wasn't the longest tank kill of World War II. That would remain a Soviet record from earlier in the war. But it was the longest confirmed kill by an American tank destroyer, achieved at the maximum range of the Jackson's telescopic sight. More importantly, it revealed something about the weapon system that specifications couldn't capture. The 90mm M3 gun possessed accuracy that exceeded expectations. When properly zeroed, with ammunition that met quality standards, the Jackson could engage targets at ranges that German crews considered safe. Corporal Anthony Pinto of the 776th Tank Destroyer Battalion achieved a similar feat weeks later, destroying a Panther at 4,200 yards. Both kills became legendary within tank destroyer units, proof that the Jackson could reach out and kill German armor before the Germans even knew they were under threat. Asterisk, asterisk. But combat isn't conducted at maximum range under perfect conditions. Asterisk, asterisk. The real test came in December 1944, when Germany launched its final major offensive through the Ardennes. Forest. The Battle of the Bulge would prove whether the M36 Jackson could perform under the worst possible circumstances. 3 tank destroyer battalions equipped with Jacksons, the 610th, 703rd, and 740th, found themselves facing the concentrated weight of German armoured formations. Panthers, Tigers, King Tigers, all supported by infantry and artillery, attacking through terrain that favoured the defender but left American forces badly outnumbered. The 703rd Tank Destroyer Battalion, attached to the 3rd Armoured Division, was rushed to St. Vith to help contain the German breakthrough. They arrived to find chaos. American units were falling back, German armour was advancing rapidly, and the entire Allied position in the Ardennes seemed at risk of collapse. The Jacksons deployed in defensive positions around St. Vith, creating an armoured screen that would have to hold long enough for reinforcements to arrive. The crews knew they were outgunned in terms of armour protection. A direct hit from any German tank gun would penetrate their thin armour and likely kill the crew. Their only advantages were firepower and rate of fire. They would have to kill German tanks before the Germans killed them. The first German armour appeared through the morning mist on December 20th. Panthers advancing in column, confident in their armour superiority, expecting American forces to retreat as they had been retreating for days. The Jacksons opened fire at 1,500 metres. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The volume of fire that erupted from the American positions shocked the German commanders. This wasn't the hesitant, ineffective fire of M10 Wolverines trying desperately to penetrate German armour with inadequate guns. This was sustained, accurate, devastating fire from weapons that could kill Panthers at ranges the Germans considered safe. The lead Panther took 3 hits in rapid succession. 2 rounds struck the turret, 1 penetrated the side armour. The tank stopped, smoke pouring from the hatches. The second Panther tried to reverse, but a Jackson from a flanking position caught it, with a side shot that penetrated the ammunition storage. The explosion tore the turret completely off the hull. Within minutes, 5 Panthers were burning. The German advance stalled as commanders tried to understand what was killing their tanks so quickly. The 703rd Tank Destroyer Battalion's after-action reports from the Battle of the Bulge document engagement after engagement following the same pattern. Jacksons would establish positions with good fields of fire, wait for German armour to close to effective range, then unleash rapid fire that destroyed or disabled German vehicles before they could respond effectively. The open-topped turret, which seemed like a fatal vulnerability on paper, proved advantageous in the close terrain of the Ardennes. Commanders could maintain better situational awareness, spotting targets more quickly than crews buttoned up in enclosed turrets. The ability to evacuate rapidly if the vehicle was hit saved crews that would have died trying to escape through bottom hatches under fire. But the Jacksons paid a price. German artillery, once it located American tank destroyer positions, could devastate the open-topped vehicles. Airbursts rained shrapnel directly into turrets, wounding or killing crews even when the vehicle itself remained operational. Tank destroyer battalions suffered casualties approaching 2/3 of their original strength during the first week of fighting, yet they held. Saint-Vith didn't fall on December 17th as German plans required. It fell on December 21st, 4 days behind schedule. Those 4 days allowed American forces to establish defensive positions that would ultimately contain the German offensive. The 703rd, 610th, and 740th Tank Destroyer Battalions were credited with destroying over 90 German tanks and assault guns during the Battle of the Bulge. Combined with other American tank destroyers, primarily M18 Hellcats, American tank destroyer forces accounted for over 300 German armoured vehicles during the campaign. A post-war study of tank destroyer effectiveness would credit the 39 tank destroyer battalions that served in Europe with destroying 1,344 German tanks and assault guns from July 1944 through May 1945. The best-performing battalion claimed 105 confirmed kills. The average battalion accounted for 34 enemy tanks, plus 17 pillboxes, 16 machine gun nests, and 24 soft-skinned vehicles. These numbers represented vindication for a doctrine that had been controversial within American military circles. Tank destroyers, with their thin armor and powerful guns, were supposed to be mobile tank killers that could respond rapidly to German armored breakthroughs. The M36 Jackson finally gave tank destroyer crews a weapon that could fulfill that mission. But numbers and statistics don't capture the human reality of what those crews experienced. December 1944. Behind the lines near Werbermont, Belgium, while the 703rd Tank Destroyer Battalion was fighting to hold Saint-Vith, their technical officers were conducting tests that would provide crucial intelligence about the Jackson's capabilities and limitations. Between engagements, when mechanical issues forced vehicles back for repair, the battalion's maintenance sections conducted systematic evaluations of the weapon system under field conditions. The testing wasn't academic. Every crew needed to understand exactly what their Jackson could and couldn't do. Lives depended on knowing the precise capabilities of their weapon. The technical officers from the 703rd set up a makeshift testing range using abandoned German armor. They had access to a captured King Tiger, its massive bulk testament to German engineering ambition. The King Tiger represented the ultimate expression of German armor philosophy: maximum protection, maximum firepower, massive weight that strained every mechanical component. The question was simple. Could the Jackson's 90mm gun penetrate the King Tiger's frontal armor? The crews already knew from combat experience that Panthers could be killed, though frontal shots remained difficult. Tigers were vulnerable from the sides and rear, but the King Tiger, with its 150mm frontal armor and 80mm side armor, represented a different challenge entirely. The 703rd's testing, documented in their December 1944 after-action reports, reached conclusions that were sobering but not surprising. With standard M82 armor-piercing ammunition, the 90mm gun could not reliably penetrate King Tiger frontal armor at any practical combat range. Even the rare T-30E16 tungsten carbide rounds achieved only marginal penetration against the parpis, glacis plate. However, the testing revealed something more useful than simple penetration data. The King Tiger's turret armor, while still formidable, was thinner than the hull armor. More importantly, the turret sides at 80mm were vulnerable to the 90mm gun at combat ranges. A well-placed shot into the turret ring, where thinner armor protected the mechanism, could disable the turret traverse and render the vehicle combat ineffective even without penetrating into the crew compartment. The 702nd Tank Destroyer Battalion proved this in actual combat near Freihaldenhoven in December 1944. A Jackson from Company B spotted a King Tiger at approximately 1,000 yards. Rather than attempting a frontal engagement that would likely prove futile, the crew maneuvered for a flank shot. When the opportunity came, They fired a single round into the King Tiger's turret side. The round penetrated, detonating inside the turret. The massive tank stopped immediately, smoke pouring from the hatches. The crew bailed out seconds before internal ammunition storage ignited. The King Tiger, Germany's most powerful tank, was destroyed by a vehicle mounting the same gun, but weighing less than half as much. This engagement exemplified the tactical doctrine that tank destroyer crews were developing through experience. Don't fight German heavy tanks on German terms. Don't try to match armor with armor or rely on frontal protection. Instead, use mobility to achieve advantageous positions. Use superior rate of fire to overwhelm German gunnery discipline, and use the 90mm gun's power to exploit vulnerabilities that German doctrine assumed were invulnerable. The psychological dimension of this new tactical reality affected both sides profoundly. German Panther and Tiger crews had spent months, in some cases years, operating with the confidence that their armor provided near-total protection from American weapons. They could advance aggressively, knowing that Sherman's 75mm guns couldn't hurt them frontally. They could engage at extended ranges, trusting that their superior optics and gunnery training would achieve kills before American tanks could close to effective range. The Jackson's appearance in October 1944 shattered that confidence. German tank commanders began receiving reports of Panthers being destroyed at ranges exceeding 1,500 meters by American tank destroyers. Initial intelligence assessments were skeptical. The M10's 3-inch gun couldn't achieve such kills. The M18's 76mm gun was better, but still inadequate at those ranges. What weapon were the Americans using? German intelligence identified the M36 by late October 1944. Initial assessments correctly noted that the vehicle mounted a powerful 90mm gun capable of threatening German heavy armor. But German reports underestimated the weapon's rate of fire and overestimated German tanks' ability to destroy Jacksons before being destroyed themselves. This miscalculation cost German armored forces dearly during the Ardennes offensive. Panther and Tiger battalions, advancing through the Ardennes, expected to face Sherman tanks and M10 tank destroyers that they could destroy with relative impunity. Instead, they encountered Jacksons that could kill Panthers at 1,500 meters and maintain such a high rate of fire that even experienced German crews found themselves overwhelmed. German tank commanders adapted their tactics, but adaptation required resources Germany no longer possessed. Proper doctrine against Jacksons required maintaining greater spacing between vehicles to prevent single tank destroyers from engaging multiple targets. It required aggressive use of infantry screens to deny Jacksons concealed firing positions. It required emphasis on long-range engagements where German optical superiority would allow first-hit kills before the Jackson could employ its rapid-fire advantage. All sensible recommendations. All impossible to implement systematically in December 1944. The 703rd Tank Destroyer Battalion's experience during the Battle of the Bulge revealed the human cost of technological advantage. Company A lost 9 crew members killed and 17 wounded during the first week of fighting around St. Vith. Most casualties came from German artillery, which could devastate the open-topped Jacksons once their positions were identified. The crews learned to fire and displace rapidly, never remaining in one position long enough for German artillery observers to coordinate effective fire. Staff Sergeant William Morrison, commanding a Jackson in the 703rd's Company B, described the experience in a letter home written in January 1945. "We know our vehicle can kill any German tank if we get the first shot, but we also know that one hit from German artillery will likely kill the entire crew. Every engagement becomes a race. Can we identify the target, range it, and destroy it before German observers call in artillery? Usually, yes. Sometimes no. The sometimes no represented the crews who didn't survive. Tank destroyer battalions fighting in the Ardennes experienced casualty rates comparable to infantry units in sustained combat. The difference was that tank destroyer crews couldn't dig foxholes or take cover. When German artillery found their positions, the crew's only protection was the thin steel of the turret sides and the hope that they could evacuate before a direct hit. Yet morale remained surprisingly high. The crews had confidence in their weapon system. They knew the Jackson could kill German armor at ranges where German tanks struggled to return effective fire. They knew their high rate of fire gave them advantages that compensated for lack of armor protection. Most importantly, they knew that American industrial capacity would replace destroyed Jacksons within weeks, while German tank losses were increasingly irreplaceable. This confidence manifested in aggressive tactics that German commanders found unsettling. American tank destroyers didn't fight defensively, despite doctrine that emphasized mobile defense. They hunted German armor actively, moving through contested terrain to establish ambush positions, engaging German columns from flanking positions, then displacing before German forces could coordinate effective response. The contrast between American and German approaches to armored warfare became starkest in the final months of the war. German armor design throughout the conflict had emphasized technical excellence and individual superiority. Tigers and Panthers were magnificent machines, precisely engineered to embody the highest standards of mechanical and ballistic protection. They were also expensive, time-consuming to produce, difficult to maintain, and required highly trained crews to operate effectively. By early 1945, Germany's ability to field these sophisticated weapons had collapsed. Panzer divisions existed primarily on paper. The few operational German tanks were scattered in small groups, defending hopeless positions without adequate fuel, ammunition, or maintenance support. Tank losses came primarily from mechanical breakdown and abandonment rather than combat destruction. The M36 Jackson embodied a fundamentally different philosophy. Good enough, right now, in large numbers. Its armor wasn't excellent, but it was sufficient for the mission. Its gun wasn't the absolute best possible weapon, but it was good enough to threaten any German tank. Its mobility wasn't exceptional, but it was adequate for tactical repositioning. Its reliability, while not perfect, far exceeded that of German heavy tanks. This philosophy allowed American forces to field tank destroyers in numbers that overwhelmed German defenses through sheer quantity. By February 1945, 26 tank destroyer battalions operated in the European theatre, most equipped with either M36s or M18s. Combined, they created an anti-armor capability that could respond to German tank threats anywhere along the front within hours. The strategic implications extended beyond simple numerical advantage. American tank destroyer doctrine assumed that vehicles would be lost and crews would need replacement. Training programs produced replacement crews continuously. Industrial production delivered replacement vehicles faster than combat could destroy them. Maintenance procedures emphasized getting vehicles back into combat quickly rather than achieving perfect repairs. German armor forces operated under opposite assumptions. Each tank was precious and largely irreplaceable. Crews received extensive training because replacement training capacity had collapsed. Maintenance procedures emphasized careful, thorough repair because vehicles couldn't be replaced if damaged beyond field repair capability. These different philosophies produced different tactical behaviors. American crews operated aggressively, accepting risks because they knew reinforcements would arrive. German crews operated cautiously, preserving their vehicles because no replacements existed. The Aberdeen Proving Ground testing that had begun in 1943 continued throughout the war. Engineers at Aberdeen analysed captured German armour, measuring plate thickness, testing ballistic resistance, documenting weld quality and metallurgical composition. This analysis revealed something that Allied intelligence had suspected but couldn't confirm until physical evidence became available. German armour quality had degraded significantly by 1944. The armour plates on Panthers captured in France showed increased brittleness compared to earlier production. When struck by armour-piercing projectiles, the plates sometimes cracked or spalled catastrophically rather than deflecting shots cleanly. Metallurgical analysis revealed the cause. Germany had lost access to critical alloying elements, particularly nickel and molybdenum, that were essential for producing high-quality armour steel. Soviet capture of key mining regions in Eastern Europe and Allied bombing of production facilities had forced German industry to use substitute alloys with inferior properties. This degradation meant that the Jackson's 90mm gun was actually more effective against late-war German armor than penetration tables suggested. Armor that should have provided protection equivalent to 140mm sometimes failed catastrophically when struck by rounds it theoretically should have resisted. American ordnance officers documented this in technical bulletins distributed to tank destroyer units in early 1945. The bulletins noted that Panthers encountered after January 1945 were more vulnerable than earlier production vehicles, and crews should exploit this vulnerability through aggressive engagement at ranges that would have been marginal against earlier armor. The war in Europe ended in May 1945 with American armored forces in complete dominance. The M36 Jackson had participated in every major campaign from the Siegfried Line through the final collapse of German resistance. Tank Destroyer Battalions equipped with Jacksons had destroyed hundreds of German tanks, supported infantry assaults against fortified positions, provided fire support during river crossings, and helped reduce German defensive positions during the final drive into Germany. The statistical record tells part of the story. From October 1944 through May 1945, American tank destroyer forces destroyed over 1,300 German tanks and assault guns. The M36, despite entering combat relatively late in time, the war accounted for a significant portion of these kills due to its superior firepower and ability to engage German heavy armor at combat ranges. But statistics don't capture the evolution of doctrine that the Jackson represented. American forces had entered the war with tank destroyer doctrine based on theoretical assumptions about how armored warfare would be conducted. The M36 forced American commanders to adapt doctrine to match reality. Tank destroyers weren't just defensive weapons waiting to respond to German armored breakthroughs. They were offensive weapons that could hunt German armor aggressively, support infantry operations, reduce fortified positions, and provide fire support that rivaled field artillery in some circumstances. The open-topped turret, initially viewed as a necessary evil to save weight, proved advantageous for these diverse missions. Commanders could maintain better situational awareness. Crews could coordinate more effectively with supporting infantry. Ammunition supply was easier when rounds didn't need to be passed through a small turret hatch. Yes, the open top left crews vulnerable to artillery and overhead threats, but in actual combat, tank destroyers spent more time supporting infantry and engaging bunkers than fighting tank versus tank battles. The versatility gained from the open turret outweighed the vulnerability it created. The M36's service didn't end with World War II. The vehicle would see combat again in Korea, where its powerful 90mm gun proved devastatingly effective against Soviet-built T-34-85s. South Korean forces received approximately 200 M36s during the Korean War, operating them as assault guns and infantry support vehicles. The Jackson's ability to destroy any North Korean or Chinese tank at combat ranges gave United Nations forces a significant advantage during the mobile phases of the Korean War. When the war stabilized into trench warfare, M36s transitioned to fire support roles, using their powerful guns to destroy bunkers and fortified positions. Some M36s remained in service with various nations into the 1990s. Yugoslavia received nearly 400 Jacksons after World War II and operated them through the Yugoslav wars of the 1990s. Serbian forces used elderly Jacksons as decoys during NATO air operations in 1999, demonstrating that even 50 years after production ended, the vehicle's silhouette remained recognizable and potentially threatening. But the M36's real legacy wasn't its service life. It was what the vehicle represented about the evolution of armored warfare. The Jackson demonstrated that in modern mechanized combat, no single advantage is decisive. Armor protection, firepower, mobility, rate of fire, crew training, industrial capacity, logistical support, all these factors interact in complex ways. The side that can optimize the combination for their specific strategic situation will often defeat the side with superior individual components. Germany built better individual tanks. American engineering couldn't match the ballistic protection of a Panther or the gun power of a King Tiger. But America built a better tank system, integrated into a better overall war machine. The Sherman provided numerical superiority and mechanical reliability. The M18 Hellcat provided speed and mobility. The M36 Jackson provided the firepower necessary to defeat German heavy armor. Together, supported by overwhelming artillery, complete air superiority, and logistics that seemed inexhaustible to German observers, these vehicles created an armored force that German technical excellence couldn't overcome. The philosophical difference extended beyond hardware into training and doctrine. American crews learned to fight aggressively, trusting that their industrial backing would replace losses. German crews learned caution, knowing their vehicles were irreplaceable. American doctrine emphasized combined arms cooperation and overwhelming firepower. German doctrine emphasized individual unit excellence and technical superiority. In 1945, America's approach proved superior. Not because American soldiers were better fighters. German tactical excellence remained formidable even in defeat. Not because American equipment was technically superior in every category. It wasn't. American success came from creating a military system optimized for industrial warfare, where production capacity, logistical sustainment, and the ability to absorb losses mattered more than individual weapon performance. The lessons learned from the M36 Jackson's development and deployment shaped American military procurement for decades. Post-war analysis of tank destroyer effectiveness validated the concept that adequate performance sustained over time defeats superior performance that cannot be maintained under field conditions. This principle informed development of every major American armored vehicle designed after World War II. The M48 Patton tank, entering service in 1952, emphasized mechanical reliability and ease of maintenance as design requirements equal to armor and firepower. The M60 tank continued this emphasis. The M1 Abrams, entering service in 1980, represented the culmination of lessons learned from World War II, with reliability and maintainability considered co-equal with combat capability. The institutional changes within American military procurement following World War II reflected hard-won understanding of the relationship between technical specifications and operational effectiveness. Durability testing became mandatory for all new weapon systems. Maintenance procedures were evaluated as rigorously as combat performance. Logistics requirements were calculated before production decisions. Supply chain sustainability became a procurement criterion. These changes, revolutionary at the time, are now so thoroughly integrated into military development that their origin in World War II experience has been largely forgotten. But anyone studying the M36 Jackson's development can see the foundation of modern American defense procurement philosophy. Universities teaching engineering management continue to use World War II tank development as case studies in system optimization. Business schools examine how organizational culture affects technical decision-making. Military academies study how doctrine must adapt to match available capabilities, rather than wishful thinking about how wars should be fought. The human stories behind the statistics deserve preservation. Lieutenant Alfred Rose, who achieved that remarkable 4,600-yard kill against a Panther, survived the war and returned home to Pennsylvania. He rarely discussed his service, considering his actions merely doing his job under difficult circumstances. The 814th Tank Destroyer Battalion's citation for valor mentioned the engagement as one among many, not recognizing how extraordinary the shot actually was. Staff Sergeant William Morrison of the 703rd Tank Destroyer Battalion, whose Jackson was knocked out by German artillery near St. Vith, survived with severe wounds. He spent months recovering in military hospitals before being discharged in late 1945. He kept a photograph of his crew standing beside their Jackson, taken in October 1944 when they first received the vehicle. 3 of the 5 men in that photograph didn't survive the war. Corporal James Webber, the loader who helped achieve those remarkable rates of fire during the 703rd's testing, was killed by artillery fire in January 1945 during the fighting to reduce the bulge. His commander wrote to Webber's family that he had been one of the best loaders in the battalion, that his skill had saved lives by allowing their Jackson to destroy German tanks before return fire arrived. The letter didn't mention that Webber's skill couldn't protect him from the artillery shell that landed directly in the open-topped turret. These were the men who tested the M36 Jackson under the harshest possible conditions. Not in controlled experiments at Aberdeen Proving Ground, though that testing remained essential, but in combat, where mistakes meant death and success meant survival to fight again the next day. Their testing revealed truths that no proving ground could duplicate. They discovered that rate of fire mattered more than armor protection when fighting from prepared positions. They learned that crew morale remained high despite casualties because confidence in their weapon compensated for vulnerability. They proved that American tank destroyer doctrine could work when given guns powerful enough to fulfill the mission. The M36 Jackson entered service too late to fundamentally change the war's outcome. By October 1944, Germany's defeat was inevitable. The Soviet Union was grinding through Eastern Europe with overwhelming numerical superiority. Allied air forces controlled the skies over Europe. American and British industrial production dwarfed German capacity. No weapon system, however capable, could reverse these strategic realities. But the Jackson changed how the final campaigns were fought. It gave American forces the ability to engage German armor confidently at ranges where previous weapons had been inadequate. It allowed tank destroyer units to operate aggressively rather than cautiously. It provided the firepower necessary to reduce German defensive positions during the final drive into Germany. Most importantly, it validated the principle that drove American weapons development throughout the war. Perfect is the enemy of good enough. The best weapon is the one that's actually present and operational when battle is joined, not the one with the most impressive specifications that's still undergoing testing or stuck in a maintenance depot awaiting parts. The Germans built technically superior tanks. The Panthers and Tigers that survived long enough to receive proper maintenance and skilled crews were formidable opponents that could dominate local tactical situations. But technically superior when everything works perfectly doesn't win wars. Good enough, present in overwhelming numbers, supported by unlimited logistics, wins wars. The M36 Jackson embodied this philosophy completely. Its armor was thin but adequate. Its gun was powerful but not the most powerful possible. Its reliability was good but not perfect. Its rate of fire was excellent due to careful ergonomic design rather than revolutionary technology. All these characteristics combined to create a weapon system that fulfilled its mission under actual combat conditions. Not ideal conditions. Not the controlled environment of testing grounds, but the mud and chaos of combat in France, Belgium, and Germany during the winter of 1944 and the spring of 1945. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.